Hello, this is Ethan. This is my P3 screencast, and I'm gonna keep this fast because this is like take 14. This is for my user space file system daemon, and getting right into it. This is my wat.h file. It has the functions that was required. I use a struct here in order to create the tree and put nodes into it. We have some helper functions as well as some other variables that I'll be using. And we're going to get right into it. This is my wad.cpp file. This is my standard destructor. Does exactly what a destructor does. This is my private constructor here. It takes in a path and initializes the variables, opens a file stream, reads the header, also reads the descriptor, and it builds the tree as well as the map that I have. And yeah, that is that. We have load wad, which is an object allocator. It just calls the constructor and creates a new instance of the wad object. And here we have get magic, which returns the magic of the wad data. We have is content, which takes in a path and returns whether or not it goes towards a content file or not, which returns true for content, false for any other scenario. We also have is directory, which does the same thing, but for a directory path instead of a content path. We have get size, which takes in a path that if it goes towards a content file, return the number of bytes within the content file. We have get contents, which copies as many bytes as possible. It takes in a path, copies as many bytes as possible up to length, and it starts from a position buffer. And yeah, that's it. And it returns the number of bytes that were read. We also have get directory, which takes in a directory path, and if it's valid, it'll output all of its children into a vector, and it'll return the size of this vector as its output. And yeah, here we have create directory, which creates a directory. Very simple. We have one for root level directory creation as well as nested directory creation, and we make sure it's for namespace directories only per the requirements. We also have create file, which creates an empty file at the path. And yeah, so basically the same thing as create directory above, but it's for a content path instead, and it follows the same procedures. We also flush after we write, and yeah, here we have write to file, so it writes into an empty but existing file using given path. And yeah, so I'm gonna just yeah for your own perusal because I have to go past. Here you have the tokenize helper function, which takes in a path and outputs its components as a vector. And then we have find node, which is another helper that takes in a path and sees if it exists within the tree. And yeah, here's my wad.fs containing the 6 functions that we need: the get attribute, make content, make directory, read, write, as well as read directory right here. And yeah, the daemon interfaced with a libwad library using this by taking user input, loading the wad object, and it uses FuseMain as an intermediary to connect everything and create the virtual file space system. From there, I'm just going to showcase this, the /test wad, and yeah, so here I'm going to unmount just in case, which I already did, and I'm going to run this right here, so /test wadfs.sh. Awesome. We're gonna cd into it /home/reptilian/mountdir ls-al just to show that. We're gonna cat mp.txt to show that it works. We're also going to one more time ls cde1m0 just to show the structure inside, and then we'll do the same for gl sorry, ls sorry, oh, what is this? cdad, yeah, ls cdos ls, and it shows the cake.jpg. And let's see, what else do I have to do? Yeah, so that's that. We're gonna copy that cake.jpg into the home reptilian just to show it. I believe it's here. We're gonna open it. There it is. And yeah, so I believe that should be it. Let's see, cd ls, and I believe I could do like nano cat here, cl, yes, we're gonna ls, and then if we nano cat again, we say yes, we'll see that it was written in here. And yeah, thank you. That's it.